Day 6 of doing a LeetCode problem every day until I get a job. Okay, welcome back, guys. Today we have question number 700, searching a binary search tree. The difficulty level is easy, so let's get through it. Let's get to it, man. The question says, you are given the root of a binary search tree and an integer val. Find a node in the binary search tree that the node's value equals val and return the subtree rooted with that node. If such a node does not exist, return null. Okay, so let's get started. First, let's make sure we understand what a binary search tree is. So in a binary search tree, the smaller numbers go to the left, larger numbers go to the right. So in this example, you see we have 4 up here, then you go to the left, we have 2. Which is smaller than 4. You go to the right, we have 7, which is larger than 4, right? Then we have, in this example, or right here, we have the number 2. You go to the left, we get 1, which is smaller than 2. You go to the right, we get 3, which is larger than 3. So that's basically how a binary search tree works. So let's see what the input says. The input says root 42713 val 2, output 213, right? So this is what we want right here. We want the 2, the 1, and the 3. Then down here it says root 42713. The val is 5, and it must not exist. The node does not exist. So that's why it returned as nil, right? Because there is no 5. It says value 5. There is no 5, so it doesn't exist. It's nil, right? But when it's not nil, right? So back to this example, when we have the number 2, we also want the 1 and the 3. We don't just want the value 2. We also want, what does it say? And return the subtree rooted with that node. So the subtree would be the 1 and the 3. So we want 2, 1, and a 3. You see what I'm saying? So let's see how we're going to do this. So first it says, well, not first, but it says if such a node does not exist, return nil. So first what we're going to do is we're going to make sure that the root exists by saying guard let root equal root, else return nil. So in Swift we say nil, we don't say null, but same thing. So let's go on to the next part of the question. Right now we want to find the subtree rooted with that node. So what we're going to do for that is we're going to say if root dot value or dot val is equal to val, we're going to return the root. Excuse me. Then we're going to come down here and we're going to say else if root dot val is greater than val, we're going to say return search bst. We'll say root dot left comma val. Then we're going to say else return search bst root dot right comma val. And that's all we need. That should be it right there. Let's see what happens. Let's run it, and it's accepted, and let's submit it. See what happens. See what it says. Boom. It's kind of slow, but hey, it works, and we're all learning. We're getting there. It's a learning process. We're not going to have the best code or the fastest code on day 6. It doesn't work like that. Now, if my code is still slow like this on day 300, we'll reassess and we'll see what the problem is. But it's only day 6, so this should be fine. Until next time, see you guys tomorrow.